Okay, good afternoon, everybody, and welcome to this CSC webinar about going from Taito to Puhti. My name is Jussi Enkovara, and I work here at CSC in high performance computing support. During the webinar, we'll discuss some general overview of Puhti, how you can get access to Puhti, things that are a bit different in Puhti than in Taito, especially the disk areas. So we will be spending some time there. And then, of course, how to actually run jobs in Puhti. As you hopefully know, Taito won't be available for CSC customers after the end of this year. So you really need to move to Puhti. And of course, we understand that there will be probably some struggle with the computing resources before our next supercomputer, Marti, will be in use. But I hope that you can still manage with Puhti. Within the presentation, I will be going through some slides, showing also some examples with my web browser, and then also doing some examples in the Puhti itself. If you have any questions, please use the chat box. Generally, I will try to answer the questions by the end of the webinar. But if there are some sort of urgent questions really related to some topic I'm just at the moment discussing, I might try to answer them already during the presentation. We already had 2 webinars about how to actually move your data from Taito first to Allas and then to Puhti. So in this webinar, we are not discussing that topic. You can look for the YouTube recordings of the previous webinars if you're interested about, or if you need more information about that. Our new Puhti cluster, in total, it has a bit over 1,000 compute nodes, which are sort of divided to 3 different parts. So there is the standard CPU part, which in many cases is quite similar to Taito. In total, there are about 680 CPU nodes, and in total, a bit less than 30,000 CPU cores. The theoretical floating point performance is 1.8 petaflops, so it's actually a bit more powerful than Sisu was. We have also, in Taito, we had also some GPU parts, but now in Puhti, there are much more of them. So there are 8 nodes with GPUs, and the theoretical floating point performance for that part is 2.7 petaflops. Physically, within the same system, there are also 240 CPU nodes, which are only for the Finnish Meteorological Institute, and these are not available for normal CSC users. In total, there are 4.8 petabytes of disk area for the work and scratch and so on in Puhti. The sort of bit more technical details. Each node, they have 2 Intel Xeon scalable processors, and the CPUs have 20 cores. So in total, there are 40 cores in each node. The clock frequency is 2.1 gigahertz. And as these support wide vector instructions, so-called AVX 512 instructions, in theory, each CPU core is twice as fast as the CPUs in Sisu and in Taito. Of course, in practice, you typically get maybe 20 to 30% improvement in performance from these CPUs. If you are doing machine learning, deep learning, inference type workloads with these CPUs, there are also special instructions that can speed up, in theory, the calculation by factor of 10. The GPU nodes, which we have 80, there are 4 GPUs per each node. So in total, there are 320 GPUs, and each GPU has 32 gigabytes of memory. So that's twice as much than in the Pascal GPUs in Taito. And there is a very fast interconnect between the nodes for parallel jobs. In CPU nodes, the interconnect provides 100 gigabyte of bandwidth, and in GPU nodes, it's 200 gigabytes per second of bandwidth. There are variety of memory configurations in Puhti. So most of the nodes, they have the sort of basic configuration with 192 gigabytes of memory per node. Then there are a couple of bit larger memory nodes, a couple of nodes with more memory, and some fast local disk. I'll discuss the fast local disk a bit more detail a little bit later on. And then there are also a few nodes with a bit less than 800 gigabytes. And then for really large memory jobs, there are a couple of 1.5 terabyte memory nodes. And as said, in the GPU nodes, there are 384 gigabytes of memory for the CPUs and 128 for GPUs. And then there is also this last fast local disk within these nodes. Okay. Okay, there was already the question about the maximum memory. So huge memory, you can use up to 1.5 terabytes. So that's the sort of largest amount of memory available. Of course, be aware that as there are not that many of these nodes, if there are lots of use for these, you might need to queue a bit longer. So getting access to Puhti, that's of course the first step. So that will be, hopefully you all are already familiar with our new customer portal, my.csc.fi, but generally, if you go there and you can just click Get Started. And okay, I sort of we're still logged in. If I log in here, apparently it remembers my sort of credentials there. I think if I actually start with the private, in any case, you should be able to log in here with your, okay, let's take a private window here. And if I go to docs.csc.fi, interesting. Sorry, my.csc.fi. And if I now say login, there is the sort of possibly you can just use your CSC username and password, or if you have a Virtu or Haka login, you can select your organization from here and log in. Once you log in here, what you will see is the sort of dashboard here that shows your default project. Default project here means only the project that is shown here, but You can see also other projects you belong here, and in the profile here, you can change which is the sort of default one. And for the projects, in principle, it's the responsibility of the project manager to apply for Puhti access. I can check, for example, this project, and you can see that okay, Puhti is not available for me. If I would be a project manager here, I would have the possibility here to apply for an access. As I'm not one, I should ask Petri Nikunen to make the sort of application. And after project manager has done that, all the members of the project will get notification that new service, in this case Puhti, is available, and then all the project members need to actually also come here and accept the terms and conditions, confirm that they want to use Puhti. You can find all this information. So our new documentation portal, docs.csc.fi, and if you go here to accounts, you will sort of find all the relevant information here. We have also some videos and so on. Also how to apply for resources, how to add services, and so on. Once you have got to access to Puhti, you can just go here under computing and system Puhti. You can find the same sort of technical details as I showed also here about the different memory configurations and so on. And here you can find an overview how to get access Puhti. So just the same way with SSH as you did with Taito. So I can just take my terminal here. I have some SSH key set up here, so I don't actually need to type the password. So that should be quite easy and familiar to previous users of Taito. And you can see also sort of links to the documentation here. One thing that is now quite different in Puhti compared to Taito are the disk areas and the sort of how they are used. So in Puhti, the home directory, which is the one where you end up when you log in, is the only user-specific directory, and it's meant only for small amount of data. And then there are two other directories available to everybody that are project-specific. So we have the so-called Projable. That's meant for sharing projects' small-scale data, and especially if you have some of your own application codes, something that all the members of projects can easily use. And then there is the Scratch, which is really the directory or disk area where you want to do your simulations. And it's in a way it's similar to the workdir in Taito, but the important difference is that that's now project-specific area. What is also different is that the quota that you request for the Scratch that consumes billing units I'll come back to the default quotas in a moment. And there is in principle also automatic cleaning of files in this scratch. So files will be deleted 90 days from last access. That's actually not active yet. It will be activated sometime in future, and you will get some notifications about that. As Scratch is not meant for permanent or semi-permanent storage of data, we have the ALA service, which you can use for storing the data. So idea really is that in Scratch, you can produce some temporary files, you can maybe analyze that, but once you're finished, you should move the relevant data to ALAS. We realized that it's somehow might be annoying that, okay, there is this cleaning, data will be deleted, but we have had quite a lot of problems in Taito and also Sisu because of the disk system filling up. So this is really needed in order to ensure good service for everybody. By default, all the files and directories that one creates under this variable or Scratch, they are accessible to all project members. Data, the default quotas, they can be found in docs.csc.fi. And I note also already here that in addition to the maximum size of data, you have also the maximum number of files that one can have is limited. So if you go back to the docs.csc.fi, you can find the disk areas here, and you can see pretty much the same information. So that we have the home, that's the personal directory. There is no cleaning for that. Then there is the project Pro Apple, which is for the project. Also no cleaning, but project specific. And then we have the Scratch. And the default quotas, they are 10 gigabytes for home, 50 gigabytes for Pro Apple, and 1 terabyte for Scratch. And maximum number of files, 100,000 files for home, same for Pro Apple, and 1 million files for Scratch. You might wonder why also the number of files needs to be limited and not only the sort of amount of data there. But basic reason is that in the file system, there are also some hard limits that how many files it can store. And if all of our 3,000 users start to put several millions of files there, that's actually more than the file system can handle. If you need more capacity in terms of, let's say you have a data set that needs 10 terabytes, you can apply for more quota. Also, if you have a specific case where you have a good reasoning that you need more files than this 1 million, for example, in Scratch, you can apply more. At the moment, that goes by sending email to the service desk, but you can find the instructions here from our documentation. What's also been different is that in Taito, there used to be this specific environment variable, workdir, for example, for accessing the work area. That's no longer available as such in Puhti. And one thing you probably realize already is that as this variable and Scratch, they are project specific. One user can have several Scratch and variable directories if they belong to the several projects. We have a command line tool that helps you for seeing that what kind of storage areas you have. So we have this CSC workspaces command, And for example, in my case, it shows that, okay, I have my home directory. What's the sort of amount of data and files I have there? And then in principle, I have 3 different projects I belong to. So there is some sort of old project. It has a bit different name here, but then there are 2 sort of more recent computational projects. So typically these names and so on here, they have the sort of form project underscore and then some number. You can see the same project numbers also in, if you go to my.csc.fi. So for example, in my dashboard, you can see that, okay, my default project with this 2002078, that's titled HPC support. Unfortunately, at the moment in command line, we don't have any tool that could show you also the sort of name of the project. So based on these bit obscure numbers, you need to know that which project actually is, but we are working on so that you could actually see the project title also here from the command line. And once again, you see that there are some documentation. If we work really a lot with a certain project, you can use this CSC workspaces set project to get these type of environment variables, scratch and variable. So I could, for example, say here CSC workspaces set, and then I can make this HPC support my default one. Okay, and a bit more demo effects. So this is apparently not working at the moment. I think there was some renew for the CSC workspaces command, so apparently it's not working at the moment. So I can just copy paste here. As said, by default, all the files and directories are visible by all the project members. So if I list here, and if you're familiar with the Unix permissions, you can see that in principle, pretty much everything here is readable and accessible also for me. So even though, for example, this test directory here is owned by some other user, I can actually access it and go there. And let's say if I go to the HPC support project, if I create here sort of my personal directory, and if I create here some new file, and look it again, you can see that it's both readable and writable by all the members of this project. And nice thing is, of course, that it will be much easier to share the data between the project members. If for some reason you want to keep stuff private, you can use the sort of Unix tools for changing the permissions. So I could, for example, take the write permission from the group out from this file. And you can see that it's now other people cannot modify that, they can just read the data. Okay. That's pretty much the sort of main thing about the disk areas. Then if you want to run applications and so on, things are very similar in Taito. So we have the module system. I can go through quick demo in a moment. And also the sort of batch job system Slurm we have, it's very similar to what we had in Taito. And if you have been using Taito, you should be familiar with the module system. So, for example, the standard Python in a Puhti, that's Python 2.7.5. But if I want to use the sort of more recent one, which has maybe some additional packages, we have the Python app module here. And if I now launch Python, you can see that, okay, now I'm using the 3.7 and so on. By default, we have some modules here. So there's the standard environment, some compilers and libraries there. And with module avail, you can see the sort of all modules and applications that are available here. About the sort of available applications, you can once again in docs.csc.fi, there is this applications part, and you can see, if you want, you can see either the alphabetic order of all applications that are installed there and where we have module available, also some instructions on how to use them, or you can get them also by disciplines. So what we have for biosciences, what for chemistry, and so on. And I'm sure there are still some applications that are existing in Taito and not yet in Puhti, but we really try to get all the important applications from Taito ported to Puhti before Taito is actually decommissioned. As said, for the running jobs, we have a Slurm here. And once again, you can find relatively detailed instructions and templates that you can copy paste from our documentation. Just in the slides, I have a few sort of key points. So, as said, there is no, in principle, such a thing as a default billing project in Puhti anymore. So you need to provide the -- account and project in your batch job scripts. Nice thing is, of course, that it's now much easier if you are working in multiple projects to sort of work with multiple of them at the same time. One thing to note also is that this in principle, this is not, that has no relation on that in which directory. So in principle, you could be doing stuff in a Scratch directory, one project, but still submit jobs. So this mostly just tells you that which project will be billed, where the billing is applied to. For parallel calculations, you can just specify the number of tasks by -- n tasks. And if communication is not critical, it might be that that will be distributed to several different nodes depending on the load of the system and how much there are stuff available. But if you really need to make sure or want to make sure that the applications runs mostly within a full nodes, one can request full nodes with -- nodes and then tasks per node setting. So both of these examples here, they would be run with 120 MPI tasks, but in this latter case, they will be limited to the 3 nodes, while for the former case, in principle, they could be run, for example, in 12 different nodes, 10 tasks in each node. It's really suggested that you also ask for the actual memory you need, because that will sort of help to get more throughput from the queuing system. I can try to make a sort of quick demo how to use. So in simplest case, I could just from here copy the contents, then in a Puhti I could go. I can do this. Generally, it's recommended that you all the sort of simulation within these project directories. And let's create a simple job here. I can just copy paste the contents here, and I would need to sort of fill in here. I might need to load some module, and then can I run it with srun. As a simple example, I will just run the sort of hostname command here, and this will be sort test. So let's request only 1 minute of time. And that's one thing that might be a bit annoying when you start is that, okay, you need to know the project here. Okay, I don't remember maybe by heart that. So I can, at this point, I can save that. And then with CSC workspaces, I can see that, okay, yeah, this is now the project I want to use. And let's go back here and copy paste that. This is so small that I can actually use now our test partition for that one. And you can see the sort of available batch job partitions here. Also the time limits. So we have just for testing, Mir can run with up to 2 nodes for 15 minutes. We have to test. Then we have the small partition for 1 node jobs. And then for largest parallel jobs, there is a large one. If you really need to run for a longer time, then there is this long run specific partition. And also, if you really need lots of memory, you can use this huge mem partition. And in GPU, in principle, we have similarly named test partition and the sort of ordinary partition. And you can see a couple of example job scripts here. So this should be now fine. And if I submit that with, I can try to check with SQ. And okay, something seems to be finished here. And we can see that, okay, yeah, there is this okay, there is question, does running jobs on test queue consume billing units? Yes, everything you do here consumes billing units. On the other hand, what you typically do on a test queue, that should be so small that it really doesn't matter in terms of billing units. And okay, you can see that there is this standard output named default by the slurm and then the job ID. And we just printed what is the sort of host name of computing node. In order to check how well you use the resources of the job, you can use this SF. And you can see that, okay, this particular job, what was the sort of my username for that one, how much CPU was utilized, what was sort of efficiency. So that was, of course, not very sensible. It didn't really consume any memory, but for a real job, you could have seen that. And you could also see a bit that how much billing units were consumed here. So billing is based on both depending on if it's used or requested resources. So for CPU hours, it's based on the Okay, there is a question that if you want to run a jobs longer than 3 days in GPU, at the moment that's not possible. Yes, we will make also the sort of presentation slides available, and there will be also the YouTube recording. Okay, about billing, so CPU time, that will be billed based on how long time you actually run there. So it's not based on how much time you request in your batch job file. Of course, it's still a good idea to try to estimate that carefully, because that will help the throughput in the queuing system. For memory, the billing is based on how much you actually request. I think I actually have in a few slides forward, I have a bit about the fast local disk. So there is also based on the requested amount. And then there is also for the storage, as I discussed previously, there is also some billing there. The default amount, 1 terabyte, for example, Scratch, that doesn't consume anything. But if you need more, that will be 50,000 billing units per year. Probably the sort of easiest way, if you need to estimate the billing, is once again, we can go to documentation here, and in billing, you have the formulas here, and then there is also this billing unit calculator. Let's see. And I can, for example, now see Puhti. I want to use button CPU cores, not any CPU, GPUs, how much memory I need, running time, 2 days, and you can see some sort of estimation that how much that would consume billing units. But I probably just want to note here is that as you notice that the GPU hours, they're much more expensive than the CPU hours. And that's also because they are, as a resource, what it actually costs to buy and run this, it's much more. So if your application can run both on GPUs and in CPUs, it's probably makes sense to try to estimate that. Does it make sense? Since you use CPUs or GPUs. Puhti, there is no machine is also available. So for graphical stuff, you can use no machine. One more note about the running jobs is that when you log in there, of course, in principle, you can do simple stuff just directly on the command line on login node. But there are only 2 login nodes available for all the users. And if someone starts to really run their long-lasting jobs or memory-intensive, that will sort of make system very unusable for a lot of users. So do not run any long-lasting or memory-intensive pre or post-processing login nodes. Few minutes, few gigabytes, that's all fine. But if it's longer, it's suggested that you should actually do interactive jobs via batch system. You can find an example how to do that in docs.csc.fi. So if you go back once again here, and let's go computing, example job scripts. And here we have the sort of interactive. So if you really need to use graphics, I said there is no machine available. So it's suggested that you use the no machine. But for simple stuff, I can actually here just request also some X11 forwarding here. And if I go now to Puhti, I can ask that, okay, I want to run in a via batch system. I need to get access to the compute nodes. But I need to do something interactive there. Once again, I give my project here, so that's always needed. So I will be doing only serial stuff. I know that I can do that in 10 minutes. And with the X11 here, I can, if needed, I could do also some graphical stuff. If I would have an interactive application that I want to use there, I could just give it there. In principle, I can just start a new terminal here. So now, depending on the load of system and so on, it might be that you need to queue for some time. So in this example, you have all instructions how you can get the sort of email notification that, okay, now the resource is available for you. And you notice that, okay, now I have an exterm here, and that actually now, that's in some compute node. And if I would like to do, for example, some analysis with Python, so I already had the module loaded there. I could have done that there. I think I made some simple analysis script. Here, so this is just some stupid plotting here. Only thing is that now, okay, it takes some time for this one to actually start it. It need to go through the GUI. So this, even though this is very simple stuff, that would be probably easier to do via the no machine. That's a bit beyond the scope of this webinar, so we might have some no machine related stuff coming in future. But you can see that, okay, there was some graphical window of launch here, some plotting and so on. So this would be the way to actually do some analysis that might require a bit more computing. Get directly to the compute node via the batch system. And once I'm done, I can exit here. There will be also Puhti shell. At the moment, we have a Taito shell. Puhti shell is not available in the future. So it will be available. It's not available at the moment. That will be made in the future. We don't know the timeline yet. Okay, there was the question about the Eurozone screen. Academic customers, it's free of charge as previously. So it's only sort of giving indication that, okay, if you would be a commercial customer, how much that would money correspond. And also maybe good reminder also for the academic customers that even though you do not have to put any real money here, you just need to apply for billing units. Ministry of Education still needs to pay for running the machines, and this is the sort of estimated amount of money that particular amount of resources might cost. But no, using CSC services for academic customers is free of charge as previously. Okay, as said, we have 40 CPU nodes, and all the GPU nodes, they have some SSD disks, bit over 3 terabytes. And for some type of workloads, For example, in quantum chemistry, there are codes Turbomole and Orca, and I know that there are some machine learning applications where one really needs to read and write lots of data to the disk during the simulation, and the sort of speed of disk is crucial. So in your patch stop, it's possible to request also these fast local disk with this GRES NVMe, and then you give how many gigabytes you need for that. And once again, if you go to the user documentation, you will find sort of more information that how to actually do that in practice. If you want to develop applications yourself, or you need to install some applications by yourself, the software stack for compilers and high performance libraries, that of course that be different than in Taito. So we have the GNU and Intel compilers available. The default compiler is Intel, but via module swap you can change the GNU one. And there are various high performance libraries for linear algebra, fast Fourier transforms, and so on available also. By default, there is the Intel MKL libraries is available as module. The default MPI library is HPCX based on OpenMPI, but there are also in some cases MP or Intel MPI. Intel MPI is also available there, might be more useful. You should probably rerun and maybe modify configure scripts, make files, and so on. And it's really sort of recommended that you install your own applications in this Project disk area, so all the project members can then easier use the applications. And once again, if you go to our documentation, there is compiling, and you can find also some sort of recommended compiler flags for getting most out of the CPUs. Also some instructions how to build GPU applications, specific details for for MPI and OpenMP shared memory parallel applications. There's a question about some of the modules that are needed in Taito but not in Puhti. Yeah, of course you can pre-build the libraries yourself. I would also suggest that you maybe send email to the service desk if it's something that might be usable for wider group of people. We might also be able to install that. But if you need to do it yourself, what's described here in chat, that you sort of pre-build themselves and then add them to a library path, LE library path, and so on, works also. Okay, that pretty much everything I had prepared now. As said, the slides and also the recording that will be made available a bit later on. I think the YouTube recording typically that's made available within a week or so. And I think we are running this same webinar again in January 21st, if I recall. There will be some announcement that, but if you have some colleagues that you know would be interested here and were not able to participate, that we will run this again, and we might have some a bit updated information. if you still, let's see if we have some questions not answered yet. ASC as such might be that it's not in Puhti. It might be the GPOV is available. So as a part of GPOV, you can use ASC. PMD also might be that it's still missing there. But as said, we are trying to add them as fast as we can. And of course, if you sort of you have some urgent needs, once again, you can contact our service desk, and we try our best to prioritize the installations. Okay, there was a question about memory specification. So if you use the sort of, let's go to the basic example here. So as it says here, memory per CPU, if you use this choice, that will be memory per core. Okay, sorry, it was about the calculator, yeah. In the calculator, I think that actually the total amount of memory. So you might need to do some math that how you basically what the sort of calculator does there is, so I think we had in billing, we have the sort of formula here. So this memory here, that's the sort of total memory, and that's sort of what the calculator does the calculation for you. Okay, when would MATLAB be available on Puhti? Unfortunately, I don't have the exact information yet when that's going to happen. I suggest that you sort of try to look to the list of here what we have by now and then, and once again I can sort of pass the request to our MATLAB team that okay, this is something that would be needed. I'm pretty sure that's sort of relatively high on the to-do list. In Puhti at the moment, yeah, there is question about long, huge mem jobs. And I think that there is 7 days is the sort of longest that one can run in huge mem. So there's this separate huge mem long run partition. Huge memory jobs for 14 days, as far as I know at the moment, they won't be available. Of course, none of this is really sort of tightly fixed, so it's of course possible to change, and it's just always that there are some compromises to be made, that how much utilization we want from the system, how long queues and so on, how long partitions and so on, and we try to take your request and your needs into account, but as said, sometimes some compromises need to be made. So if you need more than the 380 gigabytes of memory, 7 days at the moment is the longest that you can run. Okay, if no more questions, I thank you for your attendance here. And as said, if you have any questions later on, please contact the service desk. Okay, thanks. Bye.